I was telling, right, the entire whatever we have covered, so starting from the continuous development, continuous integration, continuous delivery, and continuous deployment. So in each stages, right, in each stages of the software development cycle. So that's why, guys, I always tell you, right, DevOps is not a technology, it's not a single tool, right? What it is actually, it is a mindset and it is a culture to follow. And when you following a culture, you should understand what are the stages and what are the steps you should follow, right? And then, so when you approaching this DevOps culture, you should know what the entire development life cycle of a software, right? Software development life cycle, you should must understand it. So starting from the business requirement until to the production, right? Business analysis to production. Every phases we have the continuous automations are there. And we have to get all these things do and set up in DevOps, right? So in our until Ansible part, right? So far, starting from the GitHub to Ansible, we have covered almost everything: continuous development, integration, delivery, and deployment. That's what you need to get prepared yourself and go to the interviews, right? And you can, if you are already doing the job, you can implement these things in your project, in your company, right? Everything. So the rest of the things are, which I am going to teach you is about the advanced one, and which is also in highly demand in the market, one of the containerization. How you to containerize your applications, how to achieve the microservices, right? Those things we'll discuss in our upcoming classes. Okay, and this Docker and Kubernetes also falls on the under continuous deployment part. Okay, so whenever you are going to deploy your applications, right, you can just use the containers to deploy it, or you can just use the orchestration platform Kubernetes to orchestrate on your container services, right? So after that, we can learn some infrastructure automations, right? The infrastructure automations, if you are going to build a career in your cloud engineering, then you should go with that one. But I'll just give you some basics to advanced, little intermediate level. I'll train you on the Terraform side. The next tool, whatever we are going to cover, next topic, right? Okay, so what is Docker? What is Docker? So every time I used to say, guys, whenever you are learning, right, you should always focus three things, right? What you are learning, right? What is that? Why you want to learn this? And how you will implement. How you will implement. What is that? Why you want that? And how to implement that. Three things if you keep in your mind, right? Same things you have to ask questions. What is Docker? Then you have to understand about what is Docker, right? And why you need Docker. What problem it will solve you, right? What problem it will solve yours. So if you understand that, then you have to think about how I will implement it, right? That three things if you keep in your mind, then you will do everything, right? Let's first understand what is Docker. What is Docker? Docker is a platform used to containerize the applications, right? Containerize the applications, package them with the dependencies required for your applications into the container to run. Docker is simplifying the DevOps methodology by allowing developers to create templates called images. What is Sage? developers to create images or templates, that whatever things we are going to containerize, right? Everything will be, first you have to create in a image. So what is it? Docker is simplifying the DevOps methodology by allowing developers to create templates called images, using which we can create lightweight virtual machines, which is called Docker. Lightweight virtual machine, which is called container. And Docker is making the things easier for software industries, giving them the capability to automate infrastructure, isolate the applications, maintaining the consistency, and improving the resource utilizations. All this, whatever we just see in this statement, right? Docker is making things easier for software industries, giving them the capability to automate the infrastructure, isolate the applications, maintaining the consistency, and improving the resource utilizations. These are very much important to understand. What is isolation of the application? What is maintaining the consistency? What is resource utilizations? Because of these three, containerizations is more popular. This one, two, three, right? What is that? Isolations of the application, maintaining the consistency, and resource utilizations. With these three, container is now more popular. Okay, so we'll see in details in the actions. Okay, before that, let me just explain you these particular statements, whatever we just learned. What is that? Docker is a platform used to containerize your software. Okay, now if I just try to show you that if you have one applications, okay, suppose you have one application, sorry, you have one application there, okay, and in this one application, suppose this is a Java applications. You have a Java applications. What will happen for this Java? What you need first Java to be there, right? One particular version, suppose Java 11, and you should need some Java library will be there, right? Java libraries, some libraries will be there, and some binary files will be there, right? And then you need a server, right? You need a server to host your applications. In our case, suppose we will take Tomcat server to do that, right? All these things, what will happen? Java 11 point versions, right? You have taken it, and what will happen if you don't use containerizations? If you don't use container, what will happen? You build your applications, this entire applications, you build it. What you need, this package you have to deliver to a server, okay, deliver to a server, and your applications will be deployed here. For that, these sort of things, these particular thing should be installed prior to your deployment. Should be installed prior to your deployment. Now you understand? Now, this is without containerizations. Suppose you are going to this is your app server. This is your app server. Okay. Now what you have to do? If you are just going there, okay. Now, if I just go here and talk about your, this is without containerizations. Now, if we talk about the containerizations, what will happen? Let me change the color now to something blue. What will happen now? If we are going to do the same applications to be deployed into the container, what will happen? Same applications, these particular parts you have to package together to one image file, right? To one image file. This one will be your image. This one will be your image file. So what will happen? All these things you package to your image file. We created one image. And what will happen? This image is now having Java 11, Java some libraries, some versions, binaries available, now Tomcat server available. With that, the application version, suppose you have the application version 1.2. Okay, that is you have now. So what will happen? That particular applications, right? That particular application, if you see here, 1.2 is there, right? Suppose same thing for suppose here 1.2 also there. Here also 1.2. This application version we deployed into the without containerization deployed into the app server. Okay. Now what will happen if we are using the same concept, right? Using containerization, so what will happen? So what you have to do, you have to simply package all these things, right? Your applications, your Java, Tomcat, everything packaged together here. Created one image, and you created one image. This version suppose 1.0.1 tag you created of this image. And what you need, this particular image now you can run to create containers. So what will happen? You can suppose you have 3 servers available. Your development server, right? 3 servers available here. Development server. This is suppose pre-prod server, pre-prod, and this is suppose prod, right? So what will happen here? What image it contains, if you just run this image, particular image version 1.0.1 into this development server, pre-prod server, and production server, the same application, whatever 1.2 is installed with the binaries, that will be deployed into complete server. Normally we don't deliver or don't deploy into productions directly or into the pre-prod. First it should be deployed into the development or testing server. Once it is testing success, then it will be moved to the, either you can send to pre-prod, and pre-prod quality checks, everything is done, then it will be delivered to the productions, right? Same image file will be delivered on multiple platforms. So here there will be no chances of missing any libraries, binaries, because everything is packaged. Everything is packaged together into this particular image. Now we can build this image and ship to any environment, and it will run without any problem. But in this particular case, what will happen? If you have a different app server available here, okay, what will happen? Same set of stops you should install here. And if you, instead of installing 11, if you install Java 17 here, your applications which is built under Java 11 might not work here. For that, if you containerize these applications, right, the images, because this image now contains 11 only, right, and you can ship this one and deliver to any environment to work, that without any hiccups, without any problem, it will work. That is what usage of the container. And why should we use container? To minimize. That is only one stuff I told you. There are multiple resource utilizations are there, isolations are there, right? Other parts, consistency. We just talked about the consistency. What is this consistency? All these things with the required version, suppose Java 7 versions we have installed, or Java 8 versions we have installed. Sorry, Tomcat 7 version or Tomcat 8 versions. All these things are packaged already, so everything will be here. This one. So all are in single format, and consistency will be maintained across the environments. That one part we covered. And the other things are there. What we talked, isolations of the applications, we'll see in details upcoming slides. Also the resource utilization. Okay. If you understand all these things, no, anybody, any questions ask you, you can easily answer them. Okay. And you just ask me questions also. Right. Now, okay. Now we just learned Docker, right? Containerizations. Let's see in more details about why containerizations we need, though we have the virtualizations, right? First, let's understand what is virtualization. Whatever we are working, guys, right? Virtualizations. Now, what will happen? For virtualizations, to make you understand, let me first tell you about the virtualization, then I'll explain you with the diagram also, right? So what is virtualization? Virtualization refers to importing a guest operating system on your host operating system, allowing developers to run multiple operating systems on different VMs, okay, while all of them run on the same host, thereby eliminating the need to provide extra hardware resources. Let's understand this statement, then I'll explain you in detail. Okay. While these virtual machines were introduced, they helped in the industry in many ways, such enabling multiple operating systems on the same machine, and it was cheaper than previous methods due to less impact on the infrastructure setup. If there is any failure state, it was easier to recover, faster provisioning, and increase in the IT productivity. Increase in IT productivity. Usage of the virtualizations. Now let's see in the diagram what exactly and how it helps us. Right? So suppose I have a single server here. I have a machine. I have a machine here, suppose. This is my machine. Okay. So what will happen? This particular machine, suppose having, let's suppose having this machine is having Windows 10 version operating system. Okay. And it will be having 8 GB of memory. Okay. Suppose memory I have 8 gigabyte. Okay. And processor, suppose processor I have suppose 1.8. All these things are there in this, and I have this particular machine available with me, right? So what will happen if I want to deploy applications? What will happen? I can deploy applications here. Suppose in my company I got a new project, I have to create another applications and I want to deploy that. So what will happen? I have to create suppose app 1 and I have to deploy, and suppose tomorrow again I have to deploy another application. So what I have to do? App 2. So what will happen here? In the single server or single machine, what happens? I deployed these 3 applications. So what will happen? This single machine is now overloaded, or maybe it get crashed based on the load, and you have to do more load calculations and you have to maintain it, right? All these 3 are, so everything, all, suppose this system goes down, suppose due to some issues this system goes down, what will happen? All these 3 applications will be not available. Understood? In single machines. Now that is what was happening previously. After that, what happened? Virtualization came. So what is virtualizations? Same will have same server. Suppose I have only one server. Okay, I have one server, one infrastructure I have set up with all same hardwares. Okay, what will happen? Okay, so okay, for here what will happen? Suppose if you talk about this particular single machine, and to mitigate all this problem, what you can do, you can go for another machine, right, where you can deploy the app 1. Suppose you deploy app 1 here, and for application 2, suppose you need another machine to be deployed. Okay, another machine which you can do it. Suppose this one will be app 2. What will happen here? App 1, app 2, and here suppose I just don't put it here. App install here and app 2 install here, app 1 install here. So here what happened? I got 3 infrastructure, 3 machines, 3 separate hardwares. It is too costly. It is too costly. Instead of going and buying 3 different machines or servers, what we can do, we can use virtualization. Same infrastructure will be there, and what we can do, we have to just virtualize, means we have to create virtualizations of this particular server. Suppose I need 3 virtualizations. Okay, what will happen? And this particular machines, we can get one OS, here another OS can be installed, and here another OS will be installed. Suppose here Windows Win 10, suppose here our application 1 is required to run on Windows 11, suppose Win 11, and this is suppose running Linux machine. 3 virtualizations, V1, VM1, VM2, VM3. 3 virtualizations, 3 virtual machines we created, right? So what will happen here? These 3 virtualizations, when we create 3 virtual machines, then what will happen? That particular things we are going to install 3 operating systems, 3 virtual machines, right? What will happen here now? That virtual machines we can, on the same machines, we can install now here app 1 and app 2. Now what will happen? We have only same machine, right, with the same infrastructure, but what is there? We have extra. So what will happen? 3 virtual machines are there now, but we are using the same hardware, same infrastructure, right? Same hardware and same infrastructure are there. So what will happen here? As you are using the same hardware and same infrastructure, we now saved our cost. Instead of going this one server and this one server, we reduce this particular cost now. Everything is just virtualized here on one hardware in one machine. So we now saved hardware. Okay, that is what the virtualization is done. Now, what is containerization? The containerization is a technique where virtualization is being brought containerizations to an operating system level, right? In containerizations, you virtualize the operating system resources. Now, let me just explain you these things, whatever is written. Let me explain you in diagram. You can understand easily. Okay. So, for containerizations, if you do the same things, right? Suppose we have one machine, right? And in this particular one machine, same particular hardware, right? What will happen? We have suppose this is a Linux machine, okay, and we have 8 GB of RAM, and we have 500 GB of storage, right, and 1.8 processor, and all this are there. That's okay. Now, what will happen here? In case of containerizations, what will happen? You don't have to create or install any way. Suppose I want to create containers. Suppose here one container there. Suppose 2 containers I want to create. Okay. What will happen here? The containers, whatever I created, I don't have to install OS operating systems on this machine. What will happen? The operating systems, whatever there we used, it will use the host operating systems. We don't need a guest operating system. We need a host operating system. Means suppose this is a Linux machine. Our applications, whatever is there packaged here, it will also use these machines and whatever the binaries. It will not dependent on the machines library and binary. It is totally isolated. Okay. Now we'll see in total in other diagrams. I have one here. If you see this complete picture, what will happen here? We have this virtual VMs are there. Suppose we have three virtual machines are there, three virtual machines, but the entire is kept in one server or one machine. That is your host operating system. Suppose your host operating system is Windows 10. On top of that, you have to install one hypervisor which is required to make your machine as virtual machines. Once you install, you can create three virtual machines, and three virtual machines, what will happen? You have to install the guest operating system. Guest operating system which you have to purchase and install it in this particular virtual machine. And each virtual machines for app 1, app 2, app 3, they'll use their own binaries and libraries. That's okay, but we are going to spend, though we'll mitigate the usage of hardware, but still we are going to use the same different operating system for different virtual machine. Okay, but in case of containerizations, what is happening here? What we are going to do in case of containers, we'll be using the on top of host OS. We have to just install the container engine, which is the Docker container engine. On top of that, we don't need any guest OS. So here, what will happen? We'll save our hardware cost. Same time, we'll also our operating system, right? OS. We'll save our OS also. What will happen? Lots of cost cutting here. We saved lots of money here. Now, what will happen? We create container 1, container 2, container 3. And this container 1, container 2 will have our applications, and all our applications are now isolated. Any container goes down, it will not impact anything, right? Whatever things are available, it can create immediately. This is also one type of application isolation, but we are having extra guest OS available. So in this case, what will happen? If any machine goes down, we'll have still two other machines available to make our applications to run. But if we talk about only single machine, this particular single machine, what will happen? If it goes down, means all applications will go down. Right? That is the importance of virtualization, what we talk about, and then containerizations. Okay? Now, here is a simple diagram or table of virtualizations and all. How the virtualizations is different than containerizations, right? So virtualize the hardware resources, but virtualizes only the OS resources, and it requires the complete OS installations for every VM, right? For every VM, we need guest operating systems. That is what. But here, installs container only over host operating system. Only host operating system it will be installed. A kernel is installed again for every virtualized OS. So what will happen? If we are going to install the guest OS on every VM, what will happen? For every OS, they will install the kernel, right? Every operating system, it will install their respective kernel. And for that, what will happen? It will make the entire setup as a heavy weight, because kernel is a little heavy, right? So it will make the system as heavyweight. That's why the containerizations is lightweight, because it does not require any guest operating system. Extra operating system is not required. It will run on top of host operating system, right? That's why it is lightweight. So let's see. Heavyweight, lightweight, limited performance, native performance, fully isolated, process level isolated. In this, we also get isolations. It is fully isolated. Here we get fully isolated with process level isolation. Process level isolation means that, see, here the kernel is being used for this particular processes of operating. But here it is being used separate. For each virtual machines, kernel and processes. Okay. Now that you understood about the virtualization and containerizations, right? Now let's talk about the resource utilizations. Isolations we talk about now, right? We talk about the isolations. As for our topic, we talk about now isolations. We have consistency we saw, isolations we saw. Now let's talk about the resource utilizations. How the resource utilizations be done very efficiently in usage of the containerizations or in using Docker. I will do that. Let's see this particular diagram here. Okay, and this particular diagram has very useful things to understand. Let's see. In case of virtualizations, what will happen? Suppose you have VM1, VM2, VM3, and you have total memory. Suppose 16 GB of RAM you have. What will happen here? In 16 GB of RAM, and if you are creating 3 virtual machines, you are allocating 4 GB suppose to VM1, sorry, 6 GB to VM1, 4 GB to VM2, 6 GB to VM3. And you are deploying applications separately, VM1, VM2, VM3. Applications which is running on VM1 using 4 GB of memory and another 2 GB of memory as simply sitting idle there and it's not used. That means it is totally wasted. This memory is totally wasted, right? So only 4 GB used, but we have allocated 6 GB. 4 GB used, 2 GB is the resources, 2 GB is wasted. Similarly for BM2, BM3, totally if you are seeing total waste is coming around 7 GB. Out of 16 GB, 9 GB is simply used, 7 GB is totally wasted. Same because we already have allocated, we don't know how much it will use, so we have allocated 6 GB. And these free resources, free memory, we cannot use to create any other machines which is already allocated to one machine. Here is totally wasted, right? Cannot be allocated, totally waste of memory. Now, in case of Docker and containerizations, what will happen? As it works in the process level, right? What will happen? The same 16 GB, if we allotted to each 4 GB and whatever GB is available, right? If you allotted, and you are going to use, suppose application 1 using 4 GB, 3 GB, and 6. The rest of the memories, it will not hold it. What will happen? The container, as it is using the host operating system's hardware, what will happen? It will eat that memory which is used by the application. It will consume that memory which will be occupied by the application. The rest of the memory will be free. That you can use to create another container. So that's why it says the other 7 GB can be allotted to a new container. So what will happen here? You can create another container. So in total container, 4 containers, 4 applications can run. But here what you have to do? You have to again increase the memory and again create another virtual machine, then deploy another applications. That is what the problem is. Virtualization. So the resource utilization is being done very well. So consistency we got in containerizations and using Docker, we got isolations, we got resource utilizations. These 3 things we got. That's what make the Docker very popular. Containerizations is more popular than virtualization. Though containerizations also follow the virtualization technique, okay, it is more popular. Any doubt, guys, so far? I think you would have understood very clearly whatever I just explained to you. Okay, now let's move on to the Docker architecture. So it's very simple. Docker is the very simple tool to use in DevOps and very powerful and simple and powerful. Okay, simple and powerful. So the Docker architecture we see here, it is very simple. It just uses It's just use the Docker Actor is just use the client server architecture, only client and server. So it will have client, a host, and a registry. The client is the client, the API, the CLI, or the host, the server, which will interact with the host, which will having the engines, right? Docker engine, and the registry, which will have the image to store. Okay, the image to store. Client, host, and Docker Hub. We'll just explain what are these are. Okay, let's understand in detail how this client, host, and registry works. If we just go to the diagram here, we have a client, the Docker host, we have this client, we have this Docker host, okay, and what will happen? Also, we have a registry. So, what will happen here? If you see the client, you can execute the commands CLI, build, pull, or run. This client, what will happen? This will execute the commands and that will interact to the host. That will interact with the host. So what host it is? A daemon, Docker daemon will be there. So the engine, right? Where it will, if you are just giving Docker build, what will happen? It will create the image. Suppose it will create the Docker build, it will create the image here. And Docker run, it will create the container. Who will do? Through Docker daemon it comes here. Image build comes through Docker daemon comes here. It does not directly create. If you executing something through the client, it will connect to the host and the Docker daemon, that is the Docker engine or the Docker daemon, that will decide what needs to be created, image or container. Okay, so this is a client and server architecture. They are just communicating each other, right? Then where this third party registry comes? The registry is to store the image which is created by the daemon. So we, as a user, we requested to build a Docker file which will create an image, right? That image I need to store somewhere. I need a registry. I need a binary repository where I can store the image. And that image will be stored with versions 1.2, 1.3, 1.4. All these versions will be stored here. Based on a requirement, you have to pull this one through Docker daemon. It go to the registry, pull that image, create the container. Through pull, it will go, request comes to Docker daemon. Docker daemon, see what kind of request it is. It pulls the image from Docker registry, Docker Hub registry, and then it creates the container out of that image. If you need a container to be or application to be deployed for this particular 1.3 versions, then you have to mention 1.3 versions to be pulled and create the container. So it can just pull the container and you can just pull the image to the here, and what will happen once it pull the image, it will just pull the image here, okay, and then you have to use Docker run to create the container. Docker run to create the container. We'll see in actions totally. These are very limited commands available with. If you understand clearly how it is being done, it will be easy for you to create your own things, right? So the packaging stuff, right? How you package the things. The packaging we create in an image file. Everything will be packaged in an image file. Okay, so all these things are now packaged together. Now, so now you understood all this, what the Docker client, I already have told you, same things is written here. It is a primary way of many Docker users to interact with the Docker daemon. So client is used to interact with the Docker daemon. So that is a client and server architecture, right? What is a client? To send a request. What is a server? it will accept the request and give response to the client. That's what the client server architecture runs, right? This is the client. So uses command line utility, Docker client can communicate with Docker daemon. That's what I just told you, right? And same thing, Docker daemon, it receives, helps listening request for Docker API, which is the client. It helps managing Docker objects such as image, containers, and volumes, etc. So we have to learn what these images are. These images, containers, and Docker, those are different images. Yeah? Now, suppose in case you don't want to create an image, then simply pull an image from the Docker Hub, which will be built by some other user differently. Okay, these things can be done. Docker registry to store the image. Docker is a repository, binary repository, which store the Docker images. Store the Docker images. So we can use locally and private repository registry. You can use it. So Docker Hub, you can store images publicly, also privately there. Okay. So let's see what is this Docker registry. Docker has their own registry that is actually a remote registry. Okay, remote registry. So if I just go to hub.docker.com, okay, so what will happen here? If you see, this is actually a web registry, remote registry, you can say remote registry, where is the web applications, where we store all the images here. Suppose you want to get one image of, suppose, Tomcat server or Apache server. So what you can do, search for the Apache image, suppose, sorry, Tomcat image. Let's see if I just go for Tomcat image. See, we have this particular registry will have, these are the publicly available. You can use this particular image to create containers. These are the inbuilt images which is freely available. And when you are choosing these images from the registry, right, images from the registry, you have to select which is the Docker official image. And inbuilt images you can use, but normally in companies we don't use inbuilt images. We have to build our own image, customized image. Okay, we have to build our own image, keep it in this registry. These are the public registry, these are the publicly available. Now in your company you don't have to publicly expose your applications images and all, right? What you have to do, you have to create all these things in private repository. You have to create all this in a private repository. So these are the images available. Now let's understand what is the images. So we are talking about the images and all, right? What is this image? What is this image? There are two main objects of Docker. One is the image, another one is the container. So what is image? Image is a Docker image is a type of recipe or template which can be used for creating the Docker containers, including the steps for creating the necessary software. Okay, Docker image is a type of recipe or template which can be used for creating the Docker containers. So normally what a template contains, all the instructions. You can say Docker image is also instruction file, okay, which contains all the instructions for a applications to run, to create a software, to create an applications, right? Everything will be there in the image. So if we just go back to our discussions, whatever I was doing here, we created the image here, right? So what the image now here contains, all these instructions. What is that? We need to install Java. We need to install this library. We have to install this binary. We have to install Tomcat, right? Then we have to deploy these applications. All these instructions in a command, in a template, everything will be stored in this image. Got my point? That is what the image is. All these steps will be there in the image file. Okay. When we learn creating our own customized image, right? Build our own image. That time I'll show you how we can follow the steps to do that. Okay. All these informations available. Good guys. Now what we can do here, all these images available. Now what is the container? What is the container? The container is a type of virtual machine which is created from the instructions found within the Docker image. It is a type of virtual machine which is created from the instructions found within the image. That is what the instructions I showed you, right? Whatever the instructions here are available, based on the instructions, it will create the container. It will create the container. When we run this image file, based on the instructions given, it will create the containers. Clear? Right? That's the container is. Now, we can say container is a running instance of a Docker image. Obviously, it is a child object. It will be an instance. It will be an instance of Docker image, which consists of an entire package required to run an application. So my application required Java, my application required Tomcat, my application required some library 1.1, some particular binaries, everything whatever required, it is packaged together already in the image. So the container will have the same things whenever we run it. Now you understand everything, all concept about the Docker. Hope this will be a very clear for you guys. Okay. Now let's go ahead and talk about the installations. That's all about Docker, whatever I just gave you, right? I gave you completely everything about Docker. So now you have to now see how we can install this. Okay, how we can do that. It will be very simple, and that this is a task for you, and I'll give a task. I'm not going to show you. It will be a very simple installations part, and as you are from different backgrounds of engineering and some experience, it's up to you how you will install, but I'll show you how to do that. Okay, just go to Google, search for Docker installation, Docker install. So you can just go to the get Docker or Docker engine, and here this particular website is actually giving all the informations. For if you have a Mac operating system you are using, Apple Mac, you can just go here. If for Docker desktop, if you want for Windows, you can go with and do that. And Docker desktop for Linux. Suppose I want to install for Linux, go here, and here we can get all the information how to install it. This is what the Docker desktop. But I don't need Docker desktop actually. Normally we don't need Docker desktop. We need a Docker engine to be installed there, right? So what we can do, we can just go for install Docker engine. Okay, let's go there, and here the steps for Docker engine for Mac, for all these things. Okay, let's go for suppose for Linux, and we'll have all this. See, before that you should see for the system requirements. What is the system is required? At least 4 GB of RAM. All these things are required. Okay, see, and how to install everything. All steps is given here. Okay, how to install. Suppose in Debian, go here. These are the commands. For Debian is the Ubuntu machine, right? These are the commands how to install this. And this is what actually the Docker desktop. Docker desktop, right? We don't need Docker desktop to be there, right? Simply Docker daemon, what you can install. Let's go there. Docker engine overview. These are the engine installations. Docker desktop. Okay, so the same things you have to follow to install the Docker engines also. So what happens here, if you are going to use any suppose Linux machine, suppose you are using CentOS or Amazon Linux, and what will happen, you have to just use very simple commands like Docker sudo yum install Docker or apt-get install Docker. All these things it will install Docker for you. Okay, so once you install the Docker, you can just go ahead and just check for Docker versions, Docker -- versions, and it will give you the Docker versions there. Okay, let me quickly do that for you. And don't install these things on your own personal laptop, personal machines. Everything you can do from the cloud itself, right? So you have to get a machine from the cloud and then you have to install it. I'm just going to give you very quickly one hints how you can do that. Okay, let me quickly go through. And the rest of things you have to do, or the installations you can do your own. Okay. Oh, this instance is still running. Should have stopped it. Okay, already Docker is installed on this Ubuntu machines. Okay, I don't want this. Let's stop this particular machine. It's been running for a long time. I think from last week we had done the demo, right? Since then it is running. Maybe this month I'll get a lots of bill. This is actually 30 GB and on other servers also I had created in between, right? Okay, let's see. Let's go ahead and create one more machine quickly. And suppose I'll give it as machine name as Docker. Suppose I'll go with Amazon Linux. Let's go with Amazon Linux 2. Okay, and I'll go with the free tier. It's okay to install free tier. Okay, go there. Select the key. Let's launch instance. Okay, so what will happen here? I just created a new machine which is having this particular stuffs available there, right? Now let's go view all instances there. What will happen here? Let's just wait for a few seconds. Let it get run. Okay, let's connect. I Okay, I connected to the newly created machine here. So what I can do here, I can just directly install the Docker. It will be very simple. Just use sudo yum install Docker. Yes. See, it's a very simple command, one line command. Okay, just it will install the entire Docker. Simply, if you are using Ubuntu, you have to just use apt-get install Docker -y. So it will install Docker for you also. Okay. Now installation Docker. Docker is installed. Now if I just use Docker -hyphen version, it will give the what version. See, the Docker 20.10 build number this having installed. If you want to play around with Docker, just use info. Sorry, it should be under root user. Okay. If I just do sudo Docker info. Okay. What is Sage? I just installed the Docker, but Docker daemon is not running. So what we can do, we can start the Docker daemon. So how we'll do that? Can use system ctl status Docker versus it says inactive, right? So we can now start it. System ctl start Docker. Now if I check the status, see it is now active and running. So if I just do Docker info, it will give us the complete details. See, all the Docker client. This is the client details. This is server details. This is the server details. All these details you'll find it out. So total memory, one CPU I have, total 952 megabytes memory, operating system this, kernel version this, everything, right? Machine name, right? Everything it gives you, all the informations. So it's a task for you guys. Get one machine ready, install Docker, just see the video and try to understand what concept I just explained you about the Docker. Try to make your own note, keep it with you, and try to understand what exactly this Docker is. Right? Whatever I just told you, that's okay. Just try to learn once from your side also. Just watch the video and see how recorded sessions, right? How those architectures and everything, whatever I explained, just go through once. Just install this Docker, and from and the tomorrow classes we'll talk about the executions of the various Docker commands, how we can create images, play around with images, how we can create containers, and there are lots of other commands. Okay, we are targeting to complete this by in another two classes. Okay, not take more classes. In another two classes we'll complete this talker session. So okay guys, that's all for today's class. We can see you meet tomorrow. Okay, and do practice until then. Okay guys, chalo, bye. Let me stop this recording.